Continuation of last problem of this unit. Okay, so now we were doing this last problem. Determine whether the largest time constant of the characteristic equation given below is greater than, less than, or equal to 1 second. So this is your equations. So xi omega n is equal to 1. That means the distance from xi omega n is nothing but the S plane, the distance from the psi omega n is nothing but the distance from origin to the left. So if it is 1 means this distance is minus 1. So for that, what we did here is we modified the characteristic equation by substituting z is minus 1. Then we got the root table in that one element, all the elements of z raised to minus 1 is equal to 0. So difficulty 2 arises. Now you have to take the auxiliary equation. That means you are considering the coefficients of previous array, that is z square plus 1. Now the derivative of the auxiliary equation, the coefficient of that is considered as the elements in z raised to minus 1. Then after that you need to calculate the last element. All these parameters are positive, then you can see that there is no, even though it is positive, it indicates that there is no roots on right half of z is equal to 0, right half of z is equal to 0, or right half of s is equal to minus 1. Okay, s is equal to minus 1. But the roots are on the imaginary axis. So the same way what we did for that in the previous problems, your auxiliary equation is z raised to minus 1. This is your characteristic equation in z domain. Okay, so z square minus 1, you have to divide it. When you are dividing it, you are getting z plus 1. So when you are equating, you will get the roots is at z is equal to minus 1, and another one is z is plus or minus j1, z is plus or minus j1. So yes, so you will get the when you are substituting these conditions. So one is z is minus j plus 1, but when you are converting this to s is equal to minus 1 also, you have to add this plus or minus j1. So the roots, when you are converting this to s, so that is why you are getting here s is minus 1 minus j1 and s is equal to minus 1 plus j1, like that. And one more root is there, that is s is equal to minus 1. That means s is equal to minus, when you are converting it is minus 2. That is certainly left of certainly left of z is equal to 0, z is minus 1, z is 0 line is, as you can see that this is a j axis, this is j omega, this is sigma, this is z axis, z plane with z is equal to, this is z is equal to 0. The distance we have taken as minus 1. And here, when you are dealing with z, you are getting one pole is at z is minus 1. Z is minus 1. Here it is minus 1. So this minus 1 and this minus 1, we are getting s is equal to minus 2. There is a pole at this position, as well as one is here and one is here, plus or minus j1, plus or minus j1. But when you are coming, this is for z is 0, but when you are coming to s, there is a distance of minus 1 that should be added. That is why you are getting here s is equal to minus 1 plus or minus j1. So this you should try to understand, concentrate and try to understand. Okay, and the largest time constant of the characteristic equation is 1 second. So we started with considering it as 1 second, omega n. So this will be the largest time constant. There is no time constant to this side. Largest time constant. Time constant, you know that tau is equal to 1 by xi omega n. If xi omega n is 1, then you are getting tau is equal to 1. If psi omega n, you know that this is psi omega n, this is psi omega, this is magnitude is 1. This is taken only in the negative side only. If psi omega n is 2, then time constant is 1 divided by psi omega n, 1 by 2, it is 0.5. So that is the maximum time constant or the largest time constant of the characteristic equation equal to 1 second only. If the psi omega n here, the maximum is coming here only, and it can go here. So if it is going here, psi omega n is increasing, so time constant will decrease. So maximum time constant is, you can say that it is 1 second only.